In this video, we're going to talk about an application of integration, and this is on volume of solid of revolution. All right. The volume of solid generated when the curve y equal to f of x between x equal to a and x equal to b is rotated around the x-axis is this. The integral from a to b of pi y squared dx. All right, equation 1. The volume of solid generated when the curve y equal to f of x between the limit y equal to a and y equal to b, observe the difference between this and this, is rotated around the y-axis is this. The integral from a to b of pi x squared dy. Equation 2. So when the curve is rotated around the x-axis, this is the formula for the volume of solid generated, okay, between the limits x equal to a, x equal to b. And when the curve is rotated around the y-axis, this is for x-axis and this is for what? Y-axis. The limit being y equal to a, y equal to b. This is the formula for the volume of solid generated. All right. This is the first question. The portion of the curve y equal to x squared, this is the equation of the curve, between x equal to 0 and x equal to 2 is rotated completely around the x-axis. We have to find the volume of solid that is created or generated. When the curve is rotated around the x-axis, the volume of solid created is this. The integral from a to b of pi y squared dx. All right. What is y? Y here is equal to what? S squared. So what would be y squared? Y squared is just what? S to the power of 2 all squared, which is s raised to the power 4. So y squared is s raised to the power 4. X is equal to 0, s equal to 2. So a is 0, which is the lower limit. B is 2, the upper limit. So the volume of solid generated is this. The integral from 0 to 2 of pi, what's y squared? S to the power of 4 dx. Pi is a constant, so we have pi into the integral from 0 to 2 of s to the power of 4 dx. So we have pi. Integrating this, we have s to the power of 5 all over what? 5. From 0 to 2. Okay, it's a definite integral. So we have this pi into, I can see 1 all over 5 here. So I can bring it out. I'll be having pi over 5. 1 times pi is pi. We are now left with what? X to the power of 5 from 0 to 2. So we have pi upon 5. Plug in the upper limit, that's 2 raised to the power of 5, minus plug in the lower limit. So we have pi upon 5. 2 to the power of 5 is 32. 32. This is already 0, so that's out. So we have 32 pi upon 5 units of volume. This is the volume of solid generated. The second question says, the curve y equal to x cubed from x equal to 1 to x equal to 2 is rotated completely around the y-axis. We have to find the volume of solid generated. When the curve is rotated around the y-axis, okay, the volume of solid generated is this. The integral from a to b of pi x squared dy. Y is equal to what? X cubed. Here it is x squared dy. All right, not y squared. Okay, so let us make x the subject of the formula. Making x the subject of the formula, we have to take the cube root of both sides. X will be equal to y to the power of 1 over 3. That's it. Taking the cube root of both sides. This is what we have. So if we take the square of both sides, s squared will now be equal to y to the power of 1 over 3 all squared, which is y raised to the power what? 2 all over 3. So this is what s squared is, y to the power of 2 over 3. Now check something. The limit of integration, we are supposed to have y equal to a, y equal to b, or lower and upper limits respectively. But here it is x equal to 1, x equal to 2. So let's get the corresponding value of y when x is 1 and when x is 2. When x is equal to 1, from here I can get it. If I plug in 1 for x here, 1 cube is not 1? Yes, is 1. So when x is 1, y is 1. So this point corresponds to y equal to 1. That's what it means. What if when x is 2? It means that y is equal to 2 raised to the power 3, and that's 8. So I'm not making use of this limit. Yes, I'm making use of the limit from 1 to 8. So the volume of solid generated when the curve y equal to s cubed is rotated around the y-axis is the integral from 1 to 8. You get that? 1 to 8 of pi. What's x squared? We've gotten x squared. Y to the power of 2 over 3. Y to the power of 2 upon 3 dy. So we have pi is a constant, so you can come out, we have the integral from 1 to 8 of y to the power of 2 over 3 dy. So using the rule of integration on this, we have pi into, let's integrate y to the power of 2 over 3 dy. That's y to the power of 2 upon 3 plus 1. Alright, you add 1 to the power, and then you divide by the entire sum there. From 1 to 8. From 1 to 8. So let's evaluate this. This is pi. So we have pi. 3 times 1 is 3. 3 plus 2 is 5. So y the power of 5 over 3 upon the same thing here, 5 over 3. From 1 to 8. I can see 1 all over 5 over 3 here, which is the coefficient of y to the power of 5 over 3. Yes, this I can get this as the coefficient of this. Okay, so if I bring it out, if I simplify this, I will be having 3 over 5. So if I bring 3 over 5 outside, it will now be 3 pi. Okay, 3 pi all over 5 into y to the power of 5 upon 3 from 1 to 8. So what would this give? 3 pi all over 5. Plug in the upper limit first. That's 8 to the power of 5 over 3. Plug in the lower limit. That's 1 to the power of 5 over 3. So what would this produce? 3 pi all over 5. This is in root form. This is the cube root of 8 raised to the power of 5. That's what this means. Based on the law of indices, the cube root of 8 all to the power of 5. So this will also give us the cube root of 1 to the power of 5. Is 1 actually. Everything here is equal to 1. So we have this. 3 pi all over 5. The cube root of 8 is 2. That is the number that will multiply itself 3 times to give us 8 is 2. Then 2 to the power of 5, which is 32, minus 1. Okay. The cube root of 1 is 1. 1 to the power of 5 is still 1. So this is equal to 3 pi all over 5 into 32 minus 1, which is 3 pi all over 5 into what? 31. 31 times 3 pi is 93 pi all over 5 units of volume. That's the volume of solid generated when this curve is rotated completely around the y-axis from x equal to 1 to x equal to 2. I hope you get it. Support, subscribe, like, and share this video to your friends and your classmates.